Hello, guys. I just finished a recording that had no sound, so I spent over 20 minutes speaking and recording, and there was no sound. So let's redo this. So I have a couple of questions that I would like to solve with you. Very simple questions. So today we are going to be solving linear equations. Yeah, yellow is a very bad color to use. We're just experimenting with it, but either way, let's go on. So we're going to do a couple of simple examples. So example number one has a couple of examples on it. So it's fairly simple and straightforward, and I hope it turns out so to you. So that's the first example that we have. So this example is the one that I'm going to use to demonstrate just a simple technique that we're going to be using. So if you have an equation like this and you need to be solving it, solve the equation. So you have to solve the equation, or you solve for x, or you evaluate x, or whatever it is that you need to do on this one. So the first thing you need to look at is this variable x, that is the one that you need to solve for. So everything that is going to remain on the left-hand side has to be in terms of x. So this is not in terms of x, this -5. So we need to move it to the other side. So to do that, we add 5 both sides. I didn't intend to write with green. So we are adding 5 because this is a negative, but if it was a positive, you would subtract 5. So -5 plus 5 gives you 0. So ultimately, you're going to be left with 2x. Then this is 0, so we just have 0 there. Then this is equals to 11 plus 5, that is 16. And when you have a factor of 2 multiplying x, you divide by that factor, both sides. Whatever you do on the left, you also do on the right. So 2 into 16, that is 8. And 2 into 2 is 1. So your x is equals to 8. That is like your first example. And after you've solved the linear equation, best practice is to check answer. So you need to check your answer. And to do that, you substitute the value of x that you got into the original equation. So the original equation was 2x minus 5 is equals to 11, and both sides are supposed to be equal. So 2 times 8 minus 5 is equals to 11. And 2 times 8 is 16 minus 5 is supposed to be equals to 11. 16 minus 5, that's 11, and that's 11. And when the right-hand side and the left-hand side are the same, that means you have done it right. So for all the other questions, you're going to be applying the same technique. So let's do B. In B, we are not going to be checking, or rather, I'm not going to be checking. You're going to be doing the checking yourself. So that is B for you, which is fairly simple and straightforward. So now we need to get rid of this. So to do that, we're going to add 7 both sides. And on adding 7 both sides, minus 7 plus 7, that is 0. You're going to be left with 3x is equals to 20 plus 7, that is 27. And the factor that is multiplying x here is 3. So we divide by 3 both sides. And this 3 cancels that 3, 1, 1. 3 into 3 is 1. 3 into 27 is 9. Then x is equals to 9. That is your solution for the second part. So let's move on to the other equation that we're going to be solving, which is 5x plus 10 is equals to 60. So still the same principle. We are looking at this. Since it's positive, we're going to subtract minus 10 both sides. So you're going to be left with 5x is equals to 60 minus 10, which is 50. And the factor that is multiplying x is 5. So we divide by 5 both sides. And that 5 goes into 5 once, that 5 goes into 5 once into 50, 10 times. So your x is going to be 10. And that is the solution for that. So now let's move this a notch higher. So 2, we're going to be solving some other equations, which are a bit more complex compared to the initial ones that we had. So for this part, I'm going to be doing just two examples. And I believe they're going to be good enough for you and to demonstrate the concept that we're dealing with. So this one is going to be in terms of y. So y minus 1 plus 3, y plus 2. This is equals to 5 multiplying y minus 4. So we're going to be solving for y on this equation. So what we're going to start by doing is that we're going to expand this, expand that, and expand that. And after doing that, we're going to be collecting like terms. So let's start expanding. 4 times y, that is 4y. 4 times negative 1, that is minus 4. Then we're going to be adding 3 times y, that is 3y. 3 times 2, that is going to be 6. This is going to be equals to 5 times y, that is 5y. 5 times negative 4, that is minus 20. So now we have done that part. So we're going to start on the left-hand side and collect like terms. This and that are like terms. Then also this and that are like terms. So let's start with the first pair of like terms. 4y plus 3y, that is going to be 7y. And then minus 4 plus 6, that is going to be plus 2 is equals to 5y minus 20. So what you're going to do here is that you're going to take all the terms that have y and put them on the left-hand side, and all the other values are going to go on the left, on the right, I mean. So to get rid of this term here, which is 5y, to put it to the left, you're going to subtract by 5y this side and subtract 5y that side. And to get rid of this 2, we're going to subtract with 2 here, then we're going to subtract 2 here. So what this means is that we're going to have 7y minus 5y, that is going to be 2y. Then 2 minus 2 is 0. Then 5y minus 5y, that's 0. Then minus 20 minus 2, that is going to be minus 22. So we're going to divide by 2 both sides because the factor that is multiplying y here is 2, so that we are left with y this side. So that divides that, then that is 11. So that means our y is equals to minus 11. And you can actually check that by substituting negative 11 back into the original equation that we had. So now we're going to be doing another example. So the other example that we're going to be doing is in terms of x. That's 10x plus 4. And we're going to be subtracting 9 here. And we have x minus 3. And we're going to be subtracting 1 here. And this is equals to 8 x plus 3, yeah. So we're going to be doing the same thing that we've been doing in the previous example. So we're going to be expanding these. And on expanding those, we're going to have 10 times x, that is 10x. Then 10 times 4, that is going to be 40. And we're going to have negative 9 times x, that is going to be minus 9x. Then negative 9 times negative 3, that is going to be positive 27. Then we're going to have this minus 1 here. Then 8 times x, that is going to be 8x plus 24. So after doing this, the first thing that we're going to do again is collect the like terms on the left-hand side first. So the other pair of like terms is actually this, that's a triple. That's one pair and a triple. So 10x minus 9x, that is just going to give you x. Then 40 plus 27, that is going to give you 67. And 67 minus 1 is going to give you 66. And this is equals to 8x plus 24. So now we want to get rid of this. So we want to take all the terms that have x to the left, and all of those that have don't have x, we're going to put them to the right. So we're going to subtract 8x here, and we're going to subtract 8x here, and we are going to subtract 66 here, and we're going to subtract 66 here. So that we move 66 to the other side and 8x to the other side. So x minus 8x, it gives you negative 7x. This is equals to 24 minus 66. This is just equals to minus 42. And you divide by minus 7. You divide by minus 7. And this gives you that negative, yeah. So 7 into 42, that gives you 6. Then your x is equals to 6. And you can actually check that. So, which is fairly simple. So let's do another example here, which is going to be looking slightly complicated, but it's fairly easy too. So that is 10 multiplying 1 minus x over 10 minus 10 minus x minus 1 over 100 multiplying 10 minus x, and this is all equal to 0.05. So this looks difficult, but it's fairly simple. So what we're going to do to simplify this is that we're going to multiply every term in this equation by 100 so that we get rid of this 100 that is here. So to do that, it means that we're going to be multiplying this term by 100, then we're going to multiply that term by 100, we're going to multiply this term by 100, and we're going to multiply the other term at the end by 100, so that everything turns out to be uniform. So now 10 times 100, it gives you 1,000. Then you have 1 minus x over 10. So we are just starting by simplifying everything. Minus 100 here. Then you're going to have 10 minus x. Then this 100 is going to cancel that 100. That is just going to be minus 1. 10 minus x. Then this times 100. So we move the decimal place 2 times there. So that is going to be just 5. So then now afterwards, we start expanding these. We expand them. So to expand them is fairly simple. So 1,000 times 1, that is 1,000. Then 1,000 times that, then that means it's going to be minus 100x. Then negative 100 times 10, that is minus 1,000. Then negative 100 times negative x, that is going to be positive 100x. Then negative times 10, that is minus 10. Then negative times minus x is going to be positive x. Then all of this is going to be equals to 5. Then we're going to be collecting like terms. This and that are like terms. And this and that are like terms. So in doing that, 1000 minus 1000, that is just 0. Then we're going to be left with minus 10. So minus 10 here. Then minus 100x plus 100x is going to give you 0. Then we're going to be left with just x there. Then all of this is equals to 5. So we're going to have to get rid of this value here so that it goes to the other side. So we're going to add 10, then we're going to add 10. So your x is equals to 15. So we've done the second level of complexity. So now we're going to move into example number 3. Example number 3 is going to be on word problems. So I'm going to type in the question into the keyboard, and I hope you'll be bearing with me as I copy the question from the textbook that I'm using here. So you're going to be solving these word problems with me. So the sum of 3 consecutive numbers is 276. Find the numbers. So that is going to be our A right there. So what this is telling us is that the sum of 3 consecutive numbers is 276, and we need to find those consecutive numbers. So let's just call those consecutive numbers whatever we want to call them. So I'm going to stick to the simpler or the variables that you're mostly used to. Let's call the first number x, the second number y, and the third number z. So the sum of those numbers, which is x plus y plus z, is supposed to be 276. So that is what we know, that 3 numbers added together, they're going to give you what? 276. So now we know something here. We know something here. So what we know is that these numbers are consecutive. So they're coming one after the other. So what this means is that like first number is x. And now the second number is y. But what we know is that y comes after x. So y is going to be x plus 1. Then we know that the third number z, comes after y. So this is equals to y plus 1. And remember, we already know the value of y. The value of y from that equation that we had earlier is going to be x plus 1. So we are going to have x plus 1 plus 1. So now what this means is that z is equals to what? X plus 2. And now we have these equations here. So we have y is equals to x plus 1, and we have z is equals to what? X plus 2. So the first equation right there is now in terms of x, because we've expressed y and z in terms of x. So we can actually start substituting into the first equation that we had. So there's going to be x. My x looks ugly. x plus x plus 1 plus x plus 2. So this here is your y, and this here is your z. This is supposed to be equals to 276. So we want to find those numbers. We want to find x, y, and z. So in doing this, it means that we're going to have to collect the like terms. That term, and that term. They're like terms. Then the other like terms is this term and that term on the side. So we're going to have x plus x plus x, that is going to be 3x plus 1 plus 2, that is going to be 3, is equals to 276. So we're going to have 3x is equals to, we subtract 3 here and we subtract 3 here, 273. Then we divide by 3 and we divide by 3. This 3 cancels that. Then this 3 goes into 27 9 times. Then this 3 goes into 3 1 time. So your x is going to be equals to 91. And from the earlier equations, we had y is equals to x plus 1. So this is equals to 91 plus 1. So this gives you 92. Then you had z is equals to y plus 1. And you know the value of y, which is 92. That is going to be 92 plus 1, which gives you 93. So those consecutive numbers are 91, 92, and 93. And you can actually add them and see if they indeed add to 276. So 1 plus 2 plus 3, that is 6. Then 9 times 3, that is 27. So you solve that that question. So let's do two more questions. Then we end today's session. So the second question is also fairly simple, and I hope you're going to enjoy the session that we're having today. So let me draw some geometry here. Okay, so this is what we are given, such that this becomes x, and this here becomes 4x, and this little bit here becomes 3x plus 20. So this is x. Sorry, my x doesn't look that good. So this is what we have here. So A and B are a straight line. So you need to solve for x. And what we know is that the sum of the angles on a straight line should give you 180. And with that knowledge, you could actually sum this angle here, that angle there, and that angle. They're supposed to give you 180. So we're going to have x plus 4x plus 3x plus 20. This is going to be equals to 180. 180. So you can just collect your like terms. The first 3 terms are like terms. And on collecting like terms, you have 1 plus 4 plus 3, that is 5 plus 3, that is 8x. plus 20 is equals to 180. So you can subtract 20 both sides. Then you have 8x is equals to 160. And upon dividing with 8 both sides, you're going to have x is equals to 16 divided by 8 is 20. It's going to be 20 degrees. That is the value of your x. So, which is fairly simple. So let's look for a more daunting question. But I mean, there are no daunting questions in here, but just another series of simpler questions that we're going to be dealing with. So this is going to be another text. So the next question is going to be David. David weighs 5 kg less than John, who in turn is 8 kg lighter than Paul. If their total weight is 197 kg, how heavy is each person? So that is the question right there. So what you always do, you need to start by writing down what you think and what you know about the question. So you are told that David weighs 5 kg less than John, and who in turn is 8 kg lighter than Paul, if their total weight is that. So what we can just do is that the weight of David is given in terms of the weight of John. So we could start and say John weighs just any variable. Let's just say 8 kgs. So that is like the weight of John. Then from this now, we can find the weight of David. So we are told that David weighs 5 kg less than John. So David is going to weigh A minus 5 kg, because that is like 5 kg less than John. And we are told that John is 8 kg lighter than Paul. So to find the weight of Paul, of Paul is going to be the weight of John, because I said John weighs 8 kgs less than Paul. So if we're to say, let's just say this is going to be A plus 8, because okay, let's put it this way. So Paul is going to weigh A plus 8 kg. Let's just, for arbitrary reasons, let's say we're to give the weight of John. It's fine, it's A. Let's keep it as A. The weight of David, let's say it's X. And the weight of Paul is Y. So what the question says is that the weight of John, which is A, is equals to the weight of Paul, which is Y, minus 8. And for us to find Y now that we have there is going to be plus 8 both sides. Then Y is equals to A plus 8. That is how I got this A plus 8 here. So you could find it that way. But I mean, the way we did it here is also like very simple. So now we know the weight of each and every one of them. So we can actually write these weights and sum them together, since we know that their total weight is 197. So we could have A plus X plus Y is equals to 197. And similarly, I mean, for David, you could still have X is equals to A minus 5. Yeah. So we know that we have now expressed everything in terms of A. So everything is in terms of the weight of John. So John's weight A plus the weight of David, X, which is A minus 5. So that's going to be A minus 5 plus the weight of Paul, which is going to be A plus 8. All of these are supposed to give you 197. And when you have it like this, you have to collect the like terms. So these are the like terms that you're going to be collecting. So you have 3 A's there. So this gives you 3A. Then the other like terms that you have is this term and that term. So it's going to be minus 5 plus 8. That is going to be just 3 right there. I'm not supposed to be writing with that. Plus 3 is equals to 197. Then you subtract 3 both sides. You subtract 3 both sides. So we want to find the weight of John. So John's weight is going to be 3A is equal to 197 minus 3, that is 194. So you could just punch that in the calculator and get your answer. So A, which is the weight of John, is going to be 194 divided by 3, which is roughly 64.67. If you round it to 2 significant figures. And what we know is that David weighs 5 less than the weight of John. So to find the weight of David, so that is A minus 5 kgs, and this is equals to, since we know A, that is 64.67 minus 5. So that is going to be 59.67 kgs. And let's look at the weight of Paul. weighs, that is A plus 8 kgs, and this is going to be equal to 64.67 plus 8. So this is going to give you 72.67 kgs. So what you can actually do is to add all of these together and see what you're going to be left with, or what you're going to be having at the end. So they're supposed to add up to 197. So since we've rounded off, we didn't use fractions. There's going to be a slight error right there. So 59.67 plus 64.67, then plus 72.67. So I've used my calculator on my phone. So this is going to give us, that's 64.67 plus 59.67 plus 72.67. So I think this is just for John, this is for David, and this is for Paul. So this is going to give me 197.01. And this 01 is from me rounding off, because this was a recurring decimal. So it's 64.6666 going on. So that is from rounding. And from there, you have solved for the weight of Paul, David, and John. Or the other way you could do it, if you want to have like a whole number answer when you're checking, you could just keep the decimals and use not the decimals, you could keep the fractions. You would keep this fraction as it is. Then you could use the same fraction in all of the other workings that you're going to be doing. So that was the second example, and I hope you enjoyed today's recording.